Okay, so here we are expanding on inequalities, and we are now going to be learning about compound inequalities. So we're using the same kind of graphing stuff with the closed and the open circle, so that hasn't changed. But we now have problems that are or problems or and problems. So an or problem, if the word or is in the problem, you're going to be graphing in opposite directions, like you see here. If it doesn't say or and it's all one like compounded inequality, we call that and. And that means that the lines will kind of merge in the middle. So you'll have from like one dot to another dot. So if I wanted to write an equation for these, I just need to look at what parts are shaded. So here it looks like I'm going from -3 and then I'm getting smaller. So my x is less than or equal to -3 because it's a closed circle. Here I have an open circle on 2 and I'm getting bigger. So I would say or x is bigger than 2. For the and problems, your x is going to be in the middle and your symbols are going to be on the sides. So it looks like my x is in between -4 and 1. So on this side, I'm going to have the or equal to, and on this side, I'm just going to have the less than symbol. So my x is greater than or equal to -4, but it has to be less than 1. If this helps you, you can kind of read them like half at a time. So this half tells me that x is greater than or equal to -4, but then this half is telling me that x is less than 1. And as long as both of those match what your graph is, then you're good. Okay, so our first one here is an or problem. You're going to treat these like two separate problems, and you're going to solve them separately, and then we will graph them separately but on the same graph. So let's start with the left side. So I'm going to subtract 2 from both sides to get -3x is greater than -9. Divide by -3. And here, the same thing applies when you divide or multiply by a negative. So multiply or divide by a negative, you have to flip the sign. Don't forget about that. So my sign's going to go this way, and then 9 divided by 3 is 3. All right, on my next one here, I have 2x minus 4 after I distribute is greater than or equal to 6. Add 4 to both sides. 2x is greater than or equal to 10. Divide by 2, and I get that x is greater than or equal to 5. So I'm going to put 3, 4, 5. So I know that my x has to be less than 3. So I'm going to put an open circle on 3 and then make an arrow going this way. And it has to be greater than or equal to 5. So I'm going to put a closed circle on 5 and then go towards the bigger numbers. All right, these next two examples are and problems. So as you can see, when the x is in the middle, that's when we have an and problem. So when x is in the middle, you shade in the middle. Okay, so another thing to remember here, didn't really leave enough room, let me put this at the bottom here, is that what you do to one side, you do to all three. So for example, in this first one, to get that x alone, I have to subtract 9. But if I subtract 9 from the middle, I have to also subtract 9 from the right and also subtract 9 from the left. So it cancels out in the middle, but then I have to solve both the left and the right side. So I'm going to have negative 21 here. And then I will do 16 minus 9 on the right side, so I'll be left with 7. I'm going to bring down my symbols and my 7x. And again, here I'm going to have to divide by 7. But if I divide by 7 in the middle, I have to divide by 7 on all three sides. So then I have negative 3 less than or equal to x less than 1. So I'm going to put negative 3, 0, and 1. I'm going to put a closed circle on negative 3, an open circle on 1, and then in between I'm going to make my line. Okay, on this next one. This one looks a little bit different, but we're still going to treat it the same way. So remember, when you have to get rid of a fraction, you have to multiply by the denominator. My denominator is negative 2 here, so that means I have to multiply all three sides by negative 2. So this would become negative 30. Remember, when you multiply it in the middle, it just cancels with the bottom. So my 3x minus 3 will stay the same. And this will become negative 48. Now it kind of looks like the one on the left. So I'm going to add 3 to all sides. And again, that's only going to cancel in the middle. So I'll be left with negative. Oh, hold on. Before we go in and do that, because we multiplied by a negative here, we need to flip our signs. And we need to flip both of them. Okay, so now we're going to add 3 to all of the sides. So we have negative 27. It's greater than or equal to 3x. It's greater than or equal to, and we have negative 48 plus 3. Negative 45, and then I'm going to divide all sides by 3. Because it's positive, it's all going to stay the same. So I'll have negative 9 greater than or equal to x greater than or equal to negative 15. Now I'm going to shade these. So I have negative 15 as my smallest number, and then I have negative 9, and I can just put something in the middle. I'll just pick negative 11. And these both have closed circles, so I'm going to do a closed circle on both of them, and then it's in the middle. All right, the next thing we have is a real-world application. So Enrique is planning a diet for his dog, and his dog consumes between 510 to 540 calories each day. He has 1.5 servings of dog food. How many treats can he have? So we know that for the dog food, he has 1.5 servings of that, and we're not sure how many treats he can have. So that's going to be our variable, our missing. So to start these out, I like to start pretty simple. So I know that he can have between 510 and 540. So I'm going to make my equation like this, but this right here is my meal plan. And my meal plan consists of the information that they gave me. So 1.5 servings of dog food and 15 calories per treat, which I don't know how many he's going to get. So let's expand this meal plan. So 510, and I know that he is having 1.5 servings of dog food, and I know that it's 320 calories, plus 15 calories for each treat, but I don't know how many treats he's going to get. So I have my variable right here. Okay, so now we're going to solve it kind of like we did the last two there. So the first thing we will do is 1.5 times 320, and that is 480. And we have plus 15x, and that's on the inside. And I'll just rewrite the outside. Now I have to get that x alone, so I'm going to subtract 480 from all three sides. Okay, so I'm going to start with my left side there. So 510 minus 480 gives me 30, less than or equal to 15x, less than or equal to 540 minus 480, which is 60. Then I will divide all sides by 15. So I get 2 less than or equal to x, less than or equal to 3, or 4, sorry. So this tells me that she can have between 2 to 4 treats.